I'm going to add a class into this project. It needs to be a special kind of person, something that can inherit from person but add capability. A noun that some people are, but that not all people are. I'm just going to choose to represent someone who is on Twitter. A tweeter, if you will. And a tweeter will be a person with some extra capabilities, or some extra member variables in our case, specifically a Twitter handle. Now I could create this class the same way I created the person class, by hand adding a CPP file and an H file and typing some code into them. I want to show you another way to add a class into a project, and to be honest, it's the way you'll probably use most often. Wanted you to see how to do it by hand first, and then how Visual Studio helps you. So come up here to the project, right click, choose add, and now scroll down here to class. I'll choose a C++ class. And this brings up a class wizard to help you add classes into your system. You give it a name, say tweeter. You can see that it's naming the H file and the CPP file that it's going to generate for you. I want tweeter to be inheriting from person, so to have a base class, that's the C++ terminology of person. And we'll leave this access as public for now and leave these things unchecked, because that way I don't have to explain them just yet. I'll click finish. You can see that it adds the header file tweeter.h and the CPP file tweeter.cpp to my project. It generates a constructor and a destructor for me, and implementations with nothing in them of those two methods. And you can see the appropriate includes have also been put in my file for me. I want to have strings. I'm going to make the person's Twitter handle, for example, a string. So let's add an include of string. And I'll add a private section. And a member variable for their Twitter handle. This constructor that's been generated for me doesn't take any parameters. But if a tweeter is a person, and a person has a first name, a last name, and an arbitrary number, then a tweeter has a first name, a last name, and an arbitrary number. That's the whole point of inheriting. And we'd like to have a constructor that can set them. And as well, a tweeter has a Twitter handle. So I'm going to take these three parameters from our person.h, put them in here, along with a fourth parameter for the handle. And then these will be the four parameters to the constructor in the implementation file. And again, I'm going to use the initialization syntax and initialize the parts of tweeter that are a person, as well as the part that is special in a tweeter. You might think the way to do that would be the way we did it over in person. So I'd say initialize first name to first. First name is part of person. We have a perfectly good way to get a person object initialized, and that is with its constructor. And that's what I'm going to use here. So I say I want to use the person constructor and pass in first, last, and arbitrary. And I will also initialize Twitter handle using handle. So with this approach, I'm relying on the person constructor to handle initializing the person part of tweeter, and I'm using this syntax to initialize the Twitter handle part of tweeter. I will copy from this implementation print statement to put some stuff on the screen. And in order for that to work, I'm going to need this include line. And I'm going to add the word tweeter here. And instead of putting out the first name and the last name, I'll just put out their Twitter handle. And then we'll put that down here in the destructor. Let's come back into the main class and instead of having some person only, we're going to also have some tweeters. So I'll include tweeter.h. Now, for reasons I'll explain very shortly, I'm going to comment out the inclusive person. I'm going to leave person P1 as myself and change this person to being a tweeter. And we need to pass this fourth parameter into the constructor. I don't actually know someone else's handle, so we'll use whoever, and apologies if that's someone's real Twitter handle. And just to really clarify what's happening with scope, I'm going to add another line here. Which will work best if it has the header. So we're going to construct a person. We're going to construct a tweeter. When we hit this close brace, we're going to destruct the tweeter. Then we're going to print out this line, and then we'll destruct the person. Let's let this run with Control F5. And you can see what happens. Let's pull this over a bit, let you compare the code to the output. First, we constructed the person object, then we constructed the tweeter object. As part of constructing the tweeter object, the person part of its constructor went off and said constructing someone else. And after that was complete, the derived class, the tweeter part of the constructor, went off, put the Twitter handle value basically in. We hit this close brace, and the destruction happened in the opposite order. First, we ran the derived class destructor, which said destructing tweeter at whoever, and then the compiler ran the person part of the destructor, which said destructing someone else. Then we printed out this line that says after innermost block, and finally the destructor went off for P1. This sort of order of operations, that the base part constructor happens first and then the derived part constructor, is really important. It means that code in a derived constructor can count on its base class part being fully initialized already. And it also means when you're destructing, that the derived part sort of cleans up its own stuff and then relaxes and lets the base class clean up its part. So if the base class managed a file, the derived class would know the file was still open during its destructor, and then the base class might close the file, for example. And this is a really important aspect of understanding scope and of understanding resource acquisition, is initialization. It's taken care of for you, and it's taken care of you in a specific order every time.